Let's do an exercise. It's like this. There are two DC voltage sources of 1.5 volts. We need to calculate phi A, phi B, phi C, and UAC. The question cannot be solved without any pre-given condition because phi A, phi B, phi C are respect to one reference point. We can define A as a reference point first, then phi A equals 0. In this condition, we know UAB is phi A minus phi B. And we've known UAB is 1.5 volts, phi A equals 0, so phi B equals minus 1.5 volts. It's very intuitive. Then we know UBC is phi B minus phi C. And we've solved phi B. Phi C equals minus 1.5 minus 1.5 equals minus 3 volts. According to the above discussion, we know UAC equals phi A minus phi C. So it's 3 volts. Thus, we've finished the discussion. Next, we can also define B as a reference point. Since a reference point can be designated as you like, we define B as a reference point since UAB equals phi A minus phi B. Then we know phi A equals 1.5 volts. Similarly, since UBC equals phi B minus phi C, then we know phi C equals minus 1.5 volts. Also, according to the above discussion, UAC equals phi A minus phi B equals 3 volts. Well, it's finished. Before finishing, we still need to review. See, the potential of every point changes as the reference point changes. The value of phi A, phi B, and phi C when A is a reference point is different from the ones when B is a reference point. It proves our previous reference definition. That is, the potential is the voltage from one point to the reference point. When the reference point changes, the potential changes, of course. But let's watch UAC. Its value is the same, whatever the reference point is. The conclusion is reasonable and correct. So we need to remind you, the voltage between 2 points has no relationship to the selection of the reference point.